Hello friends, welcome to part 1 of the video series on estimation of bearing capacity of shallow footings. In this video, we'll see how one can make use of Terzaghi's theory to determine the bearing capacity of the soil. So for understanding, we have taken a problem in which we have to find out the ultimate bearing capacity of a sandy soil having angle of friction phi as 36 degree and dry unit weight as 19 kilonewton per meter cube for following cases. The first case is if a strip footing is constructed over the soil having 1.5 meter width. In second case, if a square footing of size 1.5 by 1.5 meter is constructed over this soil, and in the third case, if a circular footing of 0.75 meter radius is constructed over this soil. The footings are placed at a depth of 1.5 meter below the ground surface. We have to use the Terzaghi's bearing capacity equation for the determination, and also we have to find out the percentage reduction in the bearing capacity of square and circular footing with respect to the strip footing. Now, bearing capacity factors for angle of friction corresponding to 35 and 40 degrees are given. So we have to make use of interpolation and find out the values for phi equals to 36 degree, that is the value of NC, NQ and N gamma. Now we know, as per Terzaghi's theory, the equation for ultimate bearing capacity QU is written as C into NC plus gamma into DF into NQ plus 0.5 into gamma into B into N gamma. Now since this soil is a sandy soil in which the value of C is 0, so the first term is considered as 0. Now we'll make use of interpolation, and corresponding to angle of friction of 36 degree, we'll find the value of NQ and N gamma, which comes out as 49.38 and 54 respectively. Now we'll consider the first case in which a strip footing is constructed over a sandy soil. So we'll make use of the equation, that is QU is equals to gamma into DF into NQ plus 0.5 into gamma into B into N gamma. We'll substitute the values accordingly, and on solving we'll get the value of ultimate bearing capacity as 2176.83 kilonewton per meter square. Now we'll consider case number 2 in which a 1.5 meter by 1.5 meter wide square footing is constructed over the sandy soil. So the equation will be same, but in the third term, which we called as the wedge term, in that instead of 0.5, 0.4 must be written because the shape factor is to be considered. So the equation is written as gamma into DF into NQ plus 0.4 into gamma into B into N gamma. Substituting the values, we get the value of the ultimate bearing capacity as 2022.93 kilonewton per meter square. Now in the third case, if a circular footing is constructed over the soil of 0.75 meter radius, the equation is rewritten as gamma into DF into NQ plus 0.3 into gamma into B into N gamma. Substituting the values in the above equation, where B is to be considered as the diameter of the circular footing, that is 1.5. On solving, we'll get the value of ultimate bearing capacity as 1869.03 kilonewton per meter square. Next is we'll find out the percentage reduction in the bearing capacity of a square footing with respect to strip footing. So on solving, we get the value as 7.07%. Then we'll find out the percentage reduction of a circular footing with respect to strip footing, and on solving we'll get the value of that as 14.14%. So that's all from this video. Thanks for watching.